Ruby Community Conference organized by Visuality presents Chris Hasiński, Doom. Enjoy.
All right, can you hear me? Yeah, this thing works. Great, so I'm competing this today for the shortest talk name. The competition is very fierce because Nick has this story, but I wanted to start with Doom. And Doom, of course, stands for Document Object Oriented Modeling, right? Yeah, they asked me to do something about databases, so it's a new programming part. Nah, I'm kidding, it's Doom. Yeah, so right now you can do gem install Doom, and you will get Doom, if you do have SDL installed, sorry. Why Doom? Well, it's open source, so I can actually look up the original source. It's CPU bound, so it's an interesting problem for interpreted language. And does it run Doom is a great meme. You can run Doom on anything. This is Doom running on not TypeScript, but TypeScript type system itself. It takes 90 gigs of RAM, and it runs like one frame every couple hours, but it works. This is Doom running actually on a secondary device, but the screen is a pregnancy test. This is Doom running on the CPU list on Windows. It actually spins up the processor to draw pixels. Yeah, so why not Ruby, right? Like, I wrote it. It's not complete, but what actually is Ruby Doom? Ruby Doom is three things right now. It's a WAD loader, game state and loop, and a BSP renderer. All those things sound difficult, but the WAD, it's short for where's all the data. It's a format that Doom uses to store all the assets, maps, textures, everything. It's very easy. It's a known format. Claude can do this in one shot. So it's not very difficult to write. Game state and loop, we all see Claude games, right? Like people writing games all the time. It's a button pressed, position change, nothing complicated. Claude can do this. Yeah. Then there is BSP, which is binary space partition. This is a trick that they use to make Doom run on something like 386 because it's very costly to render something in 3D, and Doom, believe me or not, is actually 3D. And the BSP is actually hard, so Claude needs some help to do this. Do you want the demo first? I don't usually do live demos, so let's do a live demo. It is Doom. It is running in Ruby. This is the game. You can actually move around. There are some interesting bugs. There is no AI in this because AI wrote this, so the people won't move. But they are there.
Can you shoot them?
No, I haven't implemented shooting because this is a very friendly conference, right? we don't shoot people here. Not yet, at least. There are some interesting bugs because Doom, for example, uses a specific type of float that I haven't implemented because I'm lazy, and that's the reason why there is a blue line over here. But you can actually go through the entire level. It works. There is like a little bounce when you move. You can open the doors. There are some interesting bugs when it comes to rendering, and also everything is frozen, which is like a frozen Doom. Maybe more fit for like a frozen Ruby conference. There is this magical bug that shows you where the secret is, because the floor is kind of highlighted. That's on accident. That shouldn't be there. And there is like one specific piece of missing ceiling. I don't know why. And Claude doesn't know why either. But I wrote some interesting code for this, like to debug this kind of edge cases. I took the, let's go back to the slides. I took the chocolate Doom, which is like a reference implementation for Doom using slightly more like modern C. And I asked Claude to write something that dumps the frame for specific location. And I was just walking around in my Doom and I asked Claude to please dump the same frame from the original Doom in the same location, compare the two, and tell me what's the difference in the rendering, because I don't know anymore. The BSP is very complex. I can show you, I wrote the original one, but at some point I just lost track of it. So it basically renders wall by wall, and you're guaranteed that the wall that you're rendering won't be overlapped by anything in the background. So this is from the engine, and at the very end, it just draws the floor and the ceiling. It's pretty cool to look at, especially if you have like multiple locations and you're trying to pinpoint, oh, this wall is wrong, or oh, the field of view is wrong for this one. But it's a tedious work, and AI doesn't really help a lot in those cases. The entire thing is divided also into sectors. So for example, in Wolfenstein, you had only like one plane, but in Doom, everything is divided into sectors, which might have a different floor height and different ceiling height, which means that you can have some more interesting maps with stairs, like pools, and a lot of different other features. But why would they actually do port Doom into Ruby? It's a great performance test. It's a really nice thing that you can use to measure, for example, what are the differences between each version of Ruby. And for example, JIT will make it 15% faster, like out of the box. If you profile it, you can get even more. You can see the things that are actually affecting performance frame to frame. Like, for example, you can manage GC if you avoid all allocations, so everything has to be reused. It's a very different pattern, so it's an interesting problem in writing those things. And it's just fun to do gem install Doom and then Doom, and it just works. This actually downloads the shareware version of Doom, so it's completely legal. As a last thing that I want to show you inside of Doom, I added some extra debugging features. One is actually showing you the sectors inside of any map. So if I move around, the different colors will mark different sectors, and every single sector has to have the same lighting, floor height, and ceiling height, which means that if I go around to some interesting place, like let's say, sorry dude, let's open this door. Hello. We're just passing by. Sorry. Yeah, so this thing has a different ceiling, and if I enable like the sector showing in the top left corner, you can see like I'm passing different sectors, and I'm basically just teleporting into locations that have like the boxes that have different ceiling height, different lighting. It's super fun to get to understand this kind of language, and also super fun to see how it interacts with something that is interpreted. So in theory, you shouldn't be able to run this. I'm doing this deep dive as a technical talk at Ruby Kaigi. There will probably be video, so if you're interested into writing a game engine in Ruby, this is something that you can look up. Thank you very much. You're welcome.